Hello, welcome. Today we are going to be looking at alkaline earth metals, the group 2 elements in the periodic table. In the previous classes, we looked at the alkaline metals, which are the group 1, example of which is sodium. So today we are going to be looking at alkaline earth metals, the group 2 elements. The group 2 elements are all metals. They are very reactive and are never found free in nature. They are known as alkaline earth metals. The elements in this group are beryllium, magnesium, calcium, strontium, and barium. Now, let's look at the most important element in this group 2, calcium. Calcium does not occur in nature since it is very reactive. It occurs in so many compounds. It occurs in the combined state as calcium triisocarbonate 4. Let's look at some of the compounds of calcium, starting with calcium oxide, also known as quicklime, with the formula CaO. Calcium oxide or quicklime is made or produced by heating calcium triisocarbonate 4. It is prepared industrially by heating lumps of limestone strongly in a furnace called a lime kiln. The limestone falls from the top of the kiln down. The kiln is heated by burning a gaseous fuel or coke. The limestone starts to decompose at around 900 degrees Celsius or 1000 degrees Celsius to give calcium oxide and carbon 4 oxide. Calcium oxide is collected at the bottom, and this is the equation of the reaction: CaCO2 to form CaO plus CO2. Another compound of calcium is calcium hydroxide. Calcium hydroxide, also called slaked lime, is a white powder which is obtained by adding water to calcium oxide. Calcium hydroxide is slightly soluble in water, and the alkaline solution is known as lime water. Another compound of calcium is calcium triisocarbonate 4, CaCO3. Calcium triisocarbonate 4 occurs abundantly as limestone, marble, chalk, etc. It is a white insoluble solid found all over as stalactites and stalagmites. Calcium triisocarbonate 4 is precipitated or produced by mixing solutions of sodium triisocarbonate 4 and calcium chloride. Sodium triisocarbonate 4 plus calcium chloride to give calcium triisocarbonate 4 and sodium chloride. Properties of calcium triisocarbonate 4. Calcium triisocarbonate 4 dissolves in water that contains dissolved carbon 4 oxide to form calcium hydrogen triisocarbonate 4. It liberates carbon 4 oxide when reacted with dilute acids. On heating, when calcium triisocarbonate 4 is strongly heated, it decomposes to give calcium oxide and carbon 4 oxide. Uses of calcium triisocarbonate 4. Limestone, which is calcium trioxocarbonate 4, is very useful in the industry. It is used in making sodium trioxocarbonate 4, calcium oxide, also known as quicklime, cement, and steel. Limestone is also used for making cement, which is a mixture of calcium trioxosilicate 4 and calcium aluminate. In the extraction of iron, limestone provides calcium oxide, which is used to remove impurities as slag. Ground limestone is used to neutralize excess acid in acidic soil. Chalk, CaCO, mixed with ammonium triisonitrate 5, known as nitro chalk, is used as fertilizer. Purification of bauxite. The bauxite is first crushed and then treated with hot sodium hydroxide solution under pressure to form soluble sodium aluminate. The impurities in the ore, the iron 3 oxide and triosilicates, which do not dissolve in the alkali, are removed by filtration. The sodium aluminate solution is transferred to certain tanks. Fresh aluminum hydroxide crystals are added as the solution cools by a process known as seeding to crystallize out aluminum hydroxide. The aluminum hydroxide is filtered, washed and heated to give pure aluminum oxide. And that is how aluminum oxide is formed. So that is where we're going to stop in. In subsequent classes, we are going to be looking at other things concerning aluminum. Please hit the subscribe button so that any video that we release will be the first to get it. Share our videos to your friends, like them. If you have any questions, please drop it on the comment section. Thank you and God bless you.